Hello everyone. The next topic which we will be discussing here is about the action potential. So action potential, if we want to define the action potential, then it is defined as a sudden, fast, transitory and propagating change of the resting membrane potential. So only the neurons and the muscle cells, they are capable of generating an action potential. So what are the examples here? So it can be only the neurons and the muscle cells that are responsible or that are capable of generating the action potential. So we will be discussing more about this and the different phases which are involved in it in more detail. So let's start with the introduction first. So what is action potential? It is a rapid rise and subsequent fall in the voltage or membrane potential across a cellular membrane with a characteristic pattern. So there is a subsequent current which is being required to initiate a voltage response in a cell membrane. So if the current is insufficient to depolarize the membrane to a threshold level, an action potential will not fire. So the examples, as I have already told you in the earlier slides, they are the neurons and the muscle cells, where the cells that signal is via the action potential. Now the next is the graph. You can see a graph which is representing the action potential. So at the top there is the action potential which is being there. So action potential involves the 5 steps. So what are these 5 steps? We will be discussing that in detail as well. So not all the stimulus, they cause the action potential. There are adequate stimulus that must have a sufficient electrolocal value which will reduce the negativity of the nerve cell to the threshold of the action potential. So here what is happening, there is a stimulus. The first step is where the stimulus is being there, and in this manner there are sub-threshold, threshold and super-threshold stimuli which is there. So in sub-threshold stimulus, they cannot cause an action potential, and threshold stimulus, they are of enough energy or potential to produce an action potential. So you can see there is a threshold which is being representing here, and super threshold stimulus also produce an action potential, but their strength is higher than that of the threshold stimulus. So when action potential is generated when stimulus changes the membrane potential to the threshold value. So when this value get changes, the action potential will starts. So the threshold potential is usually around -50 to -55 millivolts. So it is important to know that the action potential behaves upon the all or none law. So this means that any sub-threshold stimulus will cause nothing, while threshold and super threshold stimulus, they will produce a full response to the excitable cell. So from here, threshold, this part, the action potential will be given. Now, the action potential has further 3 phases: depolarization, overshoot and repolarization. So there are 2 more states of the membrane potential which is related to the action potential. That is the hyperpolarization, which precedes the depolarization, and the second is hypo and the hyperpolarization. Now, so first we will be discussing about the depolarization. So in case of depolarization, the threshold potential, it opens the gate of the sodium ion channel. So you can see there are sodium ion channels. So it opens the gate for sodium ion channels and causes a, what it causes? It causes a large influx of the sodium ion channels. So here you can see So this stage or this phase is called as the depolarization. So during depolarization, the inside of the cell becomes more and more electropositive until the potential gets closer to the electrochemical equilibrium for sodium of 61 millivolts. So this phase of extreme positivity is the overshoot phase. So the action potential, here you can see that that is at the peak, the action potential is there. So it is the overshoot phase also, you can say that here the action potential is there. Next, after this phase, the sodium permeability suddenly decreases. So the sodium permeability suddenly decreases due to the closing of its channel. So from here the channel will close and the cell potential opens up the voltage gate of the potassium ion. So there will be a rise in the potassium efflux and decreasing the cell's electropositivity. So the electropositivity of the cell will decrease here. From here it will get decreased. So this phase is known as the repolarization, whose purpose is to restore the resting membrane potential, and repolarization always leads first to the hyperpolarization, a state in which the membrane potential it is more negative. So as you can see, this is a in the negative graph, so it is always negative than the default membrane potential. But soon after that, the membrane establishes again the value of the membrane potential. So this was about it. So here is a much detail of what we have studied about the phases. So the first, in the graph itself, it was being represented first where the stimulus was there. So stimulus, it starts the rapid change in the voltage or the action potential. In a patch clamp mode, there is a sufficient current which must be administered to the cell in order to raise the voltage above the threshold value and to start the membrane depolarization. The depolarization is the phase in which there is a rapid rise of the membrane potential. So in the second stage, there was a depolarization stage in which I told you that there was an increase in the sodium ion channels in the cellular membrane and there is a larger influx of sodium ions. The next comes the repolarization stage in which the sodium ion channel there was an inactivation of the sodium ion channel, as well as the potassium ion channels will be large here from the activated potassium channels. After this stage, there comes a hyperpolarization, which we see there was a negative, that was in a negative part. So it is a lowered membrane potential, which is caused by the efflux of the potassium ions and closing of the potassium channels. After this comes the resting state. So resting state, that was the fifth stage in which the membrane potential returns to the resting voltage that occurred before the stimulus occurred. So this is all about this. So the three main events here, which I have already told you, the depolarization, where there were sodium ion channels, there was increase in the sodium ion channels and there was a large influx of the sodium ion channels. Repolarization, in which I told you that here from here the potassium ion channels will be there and it will lead to the decrease in the potassium sodium ion channels. And the next is the hyperpolarization, which is in the negative state. From here it will return to its natural state, or from here, so from here the membrane potential is more negative than the default membrane potential. So this was about the three main events of the action potential. So we have discussed all of the three events, we have discussed the graph in much more detail. So this was all about it. These are some of the references.